So, einen wunderschönen Nachmittag. Ich möchte mich ganz herzlich vorstellen. Mein Name ist Richard Hellmeier. Ich bin der Geschäftsführer der Firma Acquio und möchte Sie herzlich zu unserem Webinar begrüßen. Hello, my name is Richard Hellmeier. I'm the CEO of Acquio. I will have a short introduction in German and then we will switch into English. Ganz kurz zu Acquio. Wir sind Distributor in dem Deutschland, Österreich und Schweiz für die Security-Produkte von namhaften Herstellern. Ein Hersteller davon ist die Firma Garland. Und hier mit dem Hersteller Garland und mit Network und Security Visibility wollen wir uns heute beschäftigen. Dazu haben wir den CEO von der Firma Garland gewinnen können. Chris ist Gründer und seit langen Jahren in der Industrie und hat ein sehr, sehr profundes Wissen, was die Visibility-Lösungen betrifft. Okay, so thank you for joining and thank you everybody, and I'm highly welcome Chris. Chris is the founder and CEO of Garland, and he will today show you the Garland solution, how to increase security and network visibility, and why is it useful to use visibility solution to use Garland solution. So Chris, can you hear me? Can you?
Yes, I can.
Okay, so thank you. So it's your
Great.
turn. Thank you.
All right. Thanks a lot, Richard. Really appreciate everybody taking the time out today to see how you can help improve your security and monitoring tools within your networking environment. So with Garland Technology, one of the things that I really like to talk about with my customers, partners, is that in order to get true visibility throughout your network environment for deploying security and network monitoring tools, it really all begins with the packets flowing on the network. So I always like to say the packets tell the truth. So if you want to be able to solve problems, you want to have the ability to secure your network, we have to make sure that we have a method of instrumenting your network so you can properly secure it, monitor it, and always maintain network uptime. So today's presentation is going to be going through different use cases, and feel free to use the chat as well if you have questions, and we can answer those at the end of the presentation. When you look at an overall architecture, and we'll be diving into some more specific scenarios, but this is a great way to start to get an understanding of how you deploy and instrument your network to be able to effectively manage, monitor, and secure it. So as you can see here on the screen, we're really looking at methods of having the ability to deploy network tapping infrastructure, aggregation, packet brokers, and really you'll see that our goal is to figure out the best way to get these packets either from the actual wires of your network that are connecting your network devices, or figuring out the best methodology of getting packet level data from your private or public cloud environments. So there's two ways of deploying security and monitoring tools. And we're first going to be addressing out-of-band monitoring tools. So these are devices that allow you to collect packets out of band. This could be for performance monitoring. This could be for intrusion detection, for packet capture, for analysis. And you see here that we have a couple examples of showing how traffic can be tapped between two network devices and be able to tap and aggregate this traffic to your monitoring tools. And one deployment method that's used in deploying out-of-band tools is an option of either using span. So as you can see here on the top scenario, you can set up a span or mirrored port on your switches or routers. This does create several challenges, as well as ability to drop packets and not be able to send traffic to your security or monitoring tools. So when we look at the best way to ensure that you're going to be able to get all the packets necessary to send to your security and monitoring tools, we recommend the deployment of a network tap. So a tap gives you the ability to go actively in line between your two network devices and give a complete copy of every packet flowing. So when you're utilizing a span deployment, this is limited to copying traffic from your network switch or router. So within span ports, you have the ability to drop packets. So if you're, as an example, trying to deploy a intrusion detection system and your switch or router gets busy, you have the ability to drop packets. And the only way to 100% guarantee that you can get all the packets between two network devices is to implement a wiretap, as shown here on the right, where you have the router talking to the switch and the switch talking to the router. So we provide a full duplex copy of that traffic. So if this were a 10 gigabit link that we are tapping, you could have 10 gigabits of traffic flowing from the router to the switch. And then you could also have 10 gigs of traffic flowing from the switch to the router. So by implementing a wiretap, this gives you the ability to actually copy up to 100% utilization, which could be on a 10 gig link up to 20 gigs of traffic. So when you look at implementing these within your network and deploying your security tools, you can see where this can be very critical for applications that require all the packets. So as I mentioned earlier, you look at an intrusion detection system, or you look at a DDoS system that you're deploying. If you're using span, the deployment is immediately flawed, because if you think about what happens during a DDoS attack, you're being attacked, your routers and switches start getting high utilization, and span and mirrored ports are low priority. So what's going to happen in these situations is that your intrusion detection system or DDoS system that's hooked up to your span or mirrored port isn't going to get all the packets. You're going to start seeing drop packets in these environments. So when you look at the deployment and looking at ways that you can effectively deploy your security and monitoring tools, as we're deploying wiretaps within network environments, a lot of times your tools that you're deploying, if you're using a application firewall, you're utilizing a monitoring tool to do some troubleshooting or an analyzer, you may find that you don't need to necessarily see all the packets for the tool that you're deploying. So we're going to be getting into some use cases as well that utilize filtering technology. So what you see here in terms of improving the performance of your security and monitoring tools is by tapping the traffic, this ensures that you get all the packets going to your monitoring tools. But if you want to do some troubleshooting, maybe you want to see certain VLANs, certain IP addresses, within different technologies, we can actually do filtering and aggregation either at the tap level for your security tools, or we can introduce instrumenting a tap aggregation solution that we'll go into in a little deeper designs for some of our customers. So here we're looking at different ways of simplifying the way that you can capture packets from your network. So as you saw in the initial design, there's a lot of locations that you can tap within your network, going from your edge distribution layer to your core. So by designing a system that creates a out-of-band network solution where you're tapping the environment that you're looking to capture the traffic and bringing that into a centralized aggregation or packet broker system, this allows you to start consolidating your instrumentation and monitoring. So now you can start taking that traffic and resource sharing that to multiple tools, multiple security devices. And as you continue to grow, you'll find that there's a lot of different applications and utilization. So when you look at the way we have implemented our packet broker system, we've designed it in a very modular, purpose-built hardware system that you can do your wiretapping, your aggregation, and special features like dedupe, packet slicing. So we really allow you to deploy what you need when you need it for the security tools that you're deploying in your environment. So as you can see here, the different speeds, we're seeing that companies are growing obviously from 1 gig to 10 gig, 10 gig to 25, all the way up to 100 gig. And how can you effectively monitor that traffic and be able to centralize that to your security tools? So by looking at taking a modular approach and deploying what you need for the individual security tools or monitoring tools, this helps you simplify the ability to get access to your data and do it in a very cost-effective and systematic approach as your network infrastructure is changing. Here's a great example of looking at as you're migrating to new technologies. I don't know if anybody's utilizing 40 gig BiDi or 100 gig BiDi, but this can introduce quite a bit of challenges of how you monitor that. There's quite a few security tools that don't have the capability of having a 40 gig or 100 gig BiDi network interface card. So by utilizing a tap to aggregation, we can also do speed conversions, media conversions, and allow you to easily monitor that wire traffic. So in this scenario here, we're looking at tapping either a 40 or 100 gig BiDi solution. We bring that into our aggregation filtering. So now we can actually take that traffic and we can easily load balance it. So if you want to utilize some lower speed tools and you want to look at getting more life out of maybe your 10 gig or 25 gig analyzers or security tools, we can tap a 40 gigabit or 100 gigabit BiDi solution and bring that traffic into our aggregation packet broker level. And at that point, we can start filtering and load balancing down to multiple 10 gig analyzers that can allow you to monitor your higher speed links, but utilize the existing tools that you've already invested in. So we really like to see ways that we can help optimize your existing environment and gain access so you can continue to use the investment that you've already put in place. So when you're looking at deploying multiple tapping infrastructures, the nice thing is we do have the ability to go into multiple speeds, so we can mix and match. So as shown here, you can go into 10 gigabit, 40 gig, 100 gig environments. and allow you to bring that into a centralized, manageable system, which will allow you to get all the data that you need specific to the tools. So if you are finding that you need the ability to do packet slicing, deduplication, or timestamping for specific applications, we can add those features by implementing some of our purpose-built hardware. So when we look at the challenges of getting wire data, we've mainly been talking about getting into your infrastructure, but we're finding that many customers and partners are finding it very challenging on how do you get packets out of your VM environments, how do you get packet level data out of Azure, AWS, Google. So as you're looking to figure out ways to deploy your security and monitoring tools, we also have a virtual tapping system called Prisms. And this product solves several issues that our customers are running into. One is when you look at deploying a security tool within Microsoft Azure, they've announced about, I don't know, maybe about a year ago that they had a virtual tapping solution, and that's been put on hold for Microsoft. So if you're looking at deploying security tools and monitoring tools within your Azure system, you need to look at finding a way to get that packet level data. And we do that with our virtual tapping system as shown here. And what's nice is, just like in your on-prem environments, a lot of times you need to send traffic not just to one tool, but multiple tools. So you may need to send traffic to security, application performance monitoring, troubleshooting, packet capture. So we allow you to load sensors within your public or private and cloud environments. We allow you to be able to take that packet level data and send that to multiple security tools. So just like in your on-prem environments, you have the ability to bring traffic in and send it to multiple monitoring solutions. We also give you the ability to load balance traffic. So if you're using some sensors that are going to get oversubscribed or too much bandwidth, and we also give you that ability to also do filtering. So this is a great way to help you deploy the same type of applications you're deploying in your on-prem. So as you're transitioning over to your cloud environments, you can still deploy your security and monitoring tools and get that visibility so you can protect and improve the performance of your environments. Now we're going to get into a couple out-of-band use cases. So in the healthcare security, we've been working with several hospitals, several large healthcare environments that need to deploy in-band and out-of-band monitoring tools. So this is a simple use case of deploying your monitoring tools actively in line, and we'll be getting into some security tools in more detail, but also providing a copy to your network analyzer. So the idea is that you have the simple way of deploying an active inline device and also be able to deploy data to your IDS and your logging systems within your environment. We've deployed several 5G environments where we've been deploying 25 gigabit wire taps in a bidirectional 25 gig single mode environment, and looking at ways to be able to easily accommodate packet capture for troubleshooting and monitoring. So we worked with one of our partners in Japan and having the ability to deploy a 25 gigabit bidirectional BiDi tap. So what was unique in this is actually a single strand of fiber that's sending two different wavelengths over a simplex cable. And we had to have the ability to be able to break out the different wavelengths on the single strand utilizing our single mode BiDi wiretapping technology, and given the ability to capture up to the full 50 gigabit of traffic. So again, here was very critical to be able to get and access all the traffic and be able to send it over to the packet capture solution. A very typical application within our telecommunication customers is deploying generally fairly high density 10 gigabit, 40 gigabit, and also 100 gigabit applications, and be able to bring in multiple lengths and have the ability to load balance, aggregate and load balance the traffic to a performance monitoring tool. So in this case, we were doing a deployment at a telco with Series, where they were looking for the ability to tap multiple 10 gig, 40 gig, and be able to look at troubleshooting. So a lot of this had to do with point and click and configurations of looking at certain data. So the nice thing is the wiretaps will send all the traffic, every bit, byte, and packet to your aggregation layer. And at that point, you can start filtering and choosing what traffic you want to see, and giving the capability to effectively use your monitoring tools to help solve problems and have quick resolution to network performance issues. Where we've been seeing a lot of growth in the last 18 to 24 months is in the industrial space. So we're finding that in utilities, nuclear plants, manufacturing, that there's a big increase in the ability to monitor and secure your network as industrial environments are moving more towards an Ethernet deployment. So in this case, we're showing a deployment within a utility where there was multiple locations that they needed to centralize a packet capture and IDS solution. So as we talked about, you'll see a very typical wiretap solution going into an aggregator. And in this case, some of the locations had the ability to be home run back to the centralized aggregation, but other locations were actually combining the traffic and sending it back via a GRE tunnel. So we take the packet level data, bring it into our aggregator, we encapsulate that, and then send it to a centralized location where we decapsulate it and have the ability to send that to your IDS as well as your packet capture solution. Within the industrial space, there's also some unique requirements. So you find that in these environments, you a lot of times need to be air gapped. You can't have the ability to inject anything to the live network. So we have many wiretaps that have data diode design within it, and we also have created some data diode technology that allows you to bring traffic in, as shown here. The router's bringing in traffic. So in this case, if a customer is using a span port, span ports are bidirectional. So that gives the ability to have a potential security breach through your span port. So by implementing a data diode, you can bring traffic in and we can send that traffic out, but we eliminate any physical capability of sending traffic back to the live network. So this is a very critical application in these environments where it's just not acceptable to have any type of traffic going back to the live network from your security or monitoring tools. We've also done some deployments within the military. So we've designed some military taps. We actually have taps that are sitting in Humvees and tanks and are being deployed for full packet capture for analysis of improving communications. So we did a large deployment with the US government where they were doing exercises of deploying out in El Paso, Texas, in the desert, where they simulate a full deployment for 30 to 45 days. And every vehicle communication point was tapped, and we would have a packet capture box connected to it. So this ensured that every packet from every point within the deployment was being captured. And as well in the industrial space, we find that there's a lot of legacy, older technology. So you'll find that if you are getting involved with utilities and nuclear plants, that you're generally not seeing 40 gig or 100 gig. You're actually seeing a lot of 100 meg applications. So we designed several products that allow you to tap a 100 meg FX, 100 meg LX, which again, you probably haven't seen often in an enterprise environment, but a lot of the older technologies are still being used. We're currently working a project with for some applications on trains that are all 100 megabit copper applications. So again, having the ability to do the media conversion is very critical in some of these legacy environments. So when you look at deploying your TAP packet broker out-of-band infrastructure, it really helps you optimize your solution and provide the ability to effectively deploy all your tools, get use out of your existing tools as well. You can save a lot of money by utilizing your existing 10 gig analyzers, 10 gig security tools, and having the ability to reuse that. We're finding that in times of COVID right now, there's a lot of constraints on budgets. So by looking at using a TAP packet broker aggregation solution, we can really help still deploy your security and monitoring tools, but do it in a much more cost-effective manner, and that can help you get your projects completed under some of the tight budget restraints that people have these days. So we're going to get into some security solutions now. So the first examples were mainly focused on your, getting packets from the wire, getting packets from the cloud. When we start talking more security, we're generally talking a lot more in-band applications. So these are appliances that are physically installed actively in line. And we'll get into several scenarios of how we can help improve network uptime, as well as allow you to improve troubleshooting and really providing a best practice scenario of any time you're putting in active devices like intrusion prevention, web application firewalls, denial of service, any active blocking technology, really seeing how to better manage that, make it an easier deployment, and also improve on how you maintain those devices. So as we talked about on the top right here, this is showing just a typical out-of-band where you're taking a copy of the traffic. And when you start moving to active inline devices, by introducing an external bypass tap, this gives you a lot more flexibility to manage, support, and deploy your tools much more effectively. So when you're utilizing a bypass tap, it allows you to bring traffic in, pass it through your inline device. So by having this external device, this really gives you now full flexibility to manage it. So if you're a security engineer, one is it gives you full control over your active inline devices, so you can easily take them out of line for troubleshooting, maintenance windows, and also allow you to make sure that your upgrades and any of your troubleshooting methodologies never will cause any network downtime. So as you can see here, as traffic's coming in at the upper right-hand corner, by deploying the external tap, a couple things to keep in mind is, one is we're checking the health of that appliance. So you see that little heartbeat symbol. So we check the health of the inline device. If the inline device were to go offline for whatever reason, we will automatically either skip over the inline appliance, or if you have one of our HA models, we'll automatically send traffic to a secondary device. So again, this is giving you full control to manually take your device offline for troubleshooting. So if networking believes that there's an issue, they think it's the inline appliance, the nice thing with an external bypass tap, you can easily take it offline. And a lot of people say, well, I don't want to take my inline appliances offline, but the nice thing is when we take it offline, we still send the traffic. So we're still sending the traffic in an out-of-band mode. So your device is still getting the traffic to secure your network. It's just no longer allowing active blocking. So this gives you that flexibility to do that anytime without scheduling downtime for your network. And another important thing just in general with network taps is shown here on the bottom. If for some reason power were ever to be lost to the tap, your live network traffic still continues to flow. And the security stack at the edge of the network is continuing to grow. So, it's not like, 10 years ago when you put in one firewall and you were done. In order to, deploy multiple tools in your environment, we're finding that, you're generally deploying, an intrusion prevention, next-gen firewall, could be DDoS, data leakage. All these devices require to be inline blocking. So how do you effectively put multiple inline devices and manage it? And here's a quick example just showing how you can put in multiple inline devices. We can manage each of those individually. So if you want to do troubleshooting, you can easily take any one of these offline, still send the traffic, but have the ability to manage it. We also can tie in your out-of-band tools. So, not only are people trying to deploy their intrusion prevention system or their next-gen firewall, but they also want to do packet capture. So this is a very simple application. We like to call this the before and after, is having the ability to capture all the packets before it goes through your in-line device and after, and capture that in both directions. So this gives you the ability to manage what's happening with your inline device. So if you were to do an update, upgrade, configuration change, how do you maintain that? How do you know it actually is working? The only way to do that is to get packet level data. And we have many solutions that allow you to deploy your inline devices as well as get a copy of the traffic for your out-of-band tools. In a lot of environments, you do have an HA environment. So either an active-active or an active-passive situation. So we also have hardware that will allow you to easily deploy your inline devices in an active-passive mode or an active-active. So again, it's allowing you to easily send all your traffic to your inline tools, and we will actually check the health of the inline tool, and if for some reason it goes offline, we'll automatically send it to the secondary devices. So again, we're looking at ways of simplifying and allowing you to manage your entire security stack, regardless of what types of tools you have, be it inline or out of line. So I'm going to run through a couple quick scenarios here, and we have several financial companies that will deploy multiple inline tools. So where you will tap a link and they'll want to send that traffic to one or multiple tools, but then also send it to their network analyzers as well as their storage, and also sending it to your aggregation packet broker environment. So with this, the way the primary, secondary, and HA environments works is we'll have traffic coming in. This is your live network. We'll send all the traffic through your primary inline device, and if for whatever reason your primary goes down, we automatically send traffic to your secondary. And within these environments, we can also set up load balancing groups, but the idea is that we easily allow you to deploy multiple inline devices in series. We allow you to, if you have a situation where your bandwidth exceeds your inline tool, we can bring traffic and load balance it to multiple inline devices. So we're really looking at ways to simplify your deployment within your edge of your network for your security tools. So for us, we look at the best way to design and get the packets either from the wire, from the cloud, and figure out the best way to optimize your security tools. There's a lot of different products out there that customers are deploying. So we really team up with a lot of these companies to make it more efficient, to guarantee network uptime, to allow you to more cost effectively consolidate your traffic on your network, so you can really optimize and get the most out of all your security and monitoring tools. So we really try to make it simple, very scalable. So everything from single tap to hundreds of taps being deployed into an aggregation packet broker solution. So what we can do now is, Richard, if we want to take a look and see what questions people have.
Okay, first of all, thank you very much, Chris. It was a very, very good, I think. At the moment, there are so far no questions. So if there's any questions, please write in the Chat. Falls noch Fragen sind, bitte in den Chat schreiben, wenn noch irgendetwas unklar ist. Oder ansonsten gerne dann auch später per E-Mail. So it seems there are no questions. So I would say once again, thank you. Oh, there's one question. Oops. How did you manage the SSL decryption? That's a question.
Great. Yes. So there's a couple ways. So the diagram that we showed with the inline chaining. So what a lot of our customers are looking to do is to deploy either like an A10 solution, Symantec Blue Coat. So one of the things that we can do is we can help you connect up your SSL decryption solution. So we can bring traffic in, pass it through, let's say, an A10 networks appliance, and then we can take that decrypted traffic, pass it through one or multiple inline devices, and then we can send the traffic back through your A10 to re-decrypt it. So we allow the ability to deploy multiple inline devices so you can decrypt the traffic, pass it through your inline devices, and then re-encrypt it. And then in our Prisms Cloud solution, for our virtual tap solution, where we get packet level data from your public or private environments, we also have the ability to do SSL decryption prior to sending it to your monitoring or security tools within the cloud environment. So again, in the cloud environment, we can, with our Prism's virtual tap, we can decrypt any on-prem environments. We team up with companies like A10 Networks to give you the ability to decrypt traffic, and then we can take that decrypted traffic and pass it through multiple inline devices or send that to out-of-band monitoring tools as well.
Okay, thank you. Okay, are there any other questions? Sonst noch Fragen? Okay, so it seems there are no more questions. So once again, thank you for everybody to listening. Vielen Dank für die Teilnahme. Sie können uns gerne dann auch später noch kontaktieren. So if there is any questions, you can also reach us via email, phone, or whatever you want. And yeah, I will close the session for today and thank you again. Goodbye. Auf Wiederhören oder Wiedersehen.